Okay, so grade 11 pre-cal, this is lesson 31, simplifying rational expressions. So lesson 30, we talked about NPVs. Now what we're going to do is we're going to simplify, but you always have to do your NPVs no matter what. So let's look at this one here. We got 3x minus 6 over 2x squared plus x minus 10. First thing you do is you got to factor. So in this top one, we can take out a 3, and the bottom one, we can split that into two binomials. Okay, so this one, the 2x squared plus x minus 10 can be split into 2x plus 5 and x minus 2. Now, if you look, there's something the same that are top and bottom, x minus 2 and x minus 2. So those reduce out, so they equal 1, but you don't have to write them anymore. So all we're left with is 3 over 2x plus 5. Now, what you have to remember with the NPVs is you have to talk about your NPVs before and after you've reduced. So if we look at the top here, we can see that the denominator has two binomials in it. We set both of those equal to 0, and we found out x cannot equal 2, and x cannot equal negative 5 over 2. So we have two NPVs. Don't make the mistake of just doing the one. So if you do it just down here for this bottom one, you've done it wrong. Make sure you have it for both. Okay, so the next one, we have 1 minus t and t squared minus y. Well, the problem with this one is if you look at the top, it's backwards to the way we normally do it. So let's flip it around. So negative t plus 1. There we go. And the bottom part is just a difference of squares, t minus 1, t plus 1. So this top one, what we can do is we can take out a negative 1. So we take out negative 1, and we end up with t minus 1 on the top. And if you look, there's a t minus 1 on the bottom, so those reduce out. So we're left with just negative 1 over t plus 1. Now, don't forget that negative is up the top there. It's still negative 1. Now, for your NPVs, you have to realize you've got to look at the denominator. So we have t equal to 1 and t minus 1 and t plus 1. Well, t is not equal to plus or minus 1. You could write it out separately. You could say t is not equal to 1 and t is not equal to negative 1, but this is a shorter way of writing if you do the plus minus. All right, look at the last one here. So rational expressions with pairs of non-permissible values. So if you look here, what we got is we have x's and we have y's. Oh boy. But we can still factor this. So look at the top one. This is a difference of squares. 16x squared breaks down to 4x and 4x. 9y squared breaks down to 3y and 3y. And you can see that it's a negative, so the signs are different. This one, we can take out a 2. So we end up with 2 and then 4x minus 3y. Okay, look. 4x minus 3y. We can reduce those out. Nice. Now, so we're left with 4x plus 3y over 2. But you have to talk about NPVs. So in this case, there's no NPV down there, but you have to go back to the original. You can see the original is 4x minus 3y. Now we have two variables in there. Doesn't matter. Set it equal to 0 and solve it for either x or solve it for either y. So in this case, we solve it for x. So x cannot equal 3y over 4. So then what we can do is the expression for non-permissible values of x equals 3y over 4, you can do some examples if you want. So what happens, for instance, if y was 1? This is easier to kind of go backwards if y was 1. Well, 3 times 1, yeah, 3 over 4. So x is 3 over 4. All right, and you do the same thing with 2, right? 3 times 2 is 6 over 4. That breaks down to 3 over 2. Nobody ever said you had to do x first. You can do your y first if it makes it easier. Then a y value of 3. So 3 times 3 is 9 divided by 4. That's the same thing. So these are examples, and there's a whole bunch of examples for this question when it comes to non-permissible values. Okay, so lesson 31, factor, then simplify, but always do your NPVs of the bottom numbers, or sorry, the denominator before anything happens. And sometimes, like this question, you're going to have to rearrange stuff. Okay.